And in this lab, I used a round container as my object. I will create a computational model to compare to my observations using key physics concepts. I will also be using Tracker to extract the object's position and time, creating my experimental model, and I'll be using GlowScript to create my computational model. I predict that my observations will be very similar to the computational model. And in this lab, I expect to see the object's position change at a constant velocity. Some key physics concepts that I use in this lab. First, we have Newton's first law, which states that an object at rest or in motion will remain at rest or in motion unless acted upon by an unbalanced force. Secondly, we have Newton's second law, which states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. And finally, we have constant velocity, which states that an object in motion is moving in a straight line at constant speed, and this occurs when the net force is zero. Some equations that I'll be using in this lab is the position update formula. And since the velocity in this lab is constant, the average velocity will be equal to initial velocity. Next, we have the equation for average velocity, which is simply change in position divided by change in time. And third of all, we have velocity update formula, which since we are focusing on constant velocity in this lab, the net force shown here will be zero. And here's a video showing the tracker analysis of the container in motion. As you can see, the container moves from left to right, which means the position will be measured in the positive direction. And I set the origin to the center of the container. As you can see over here in the graph, as time increases, position also increases, resulting in the positive slope. Here's the data that I obtained from Tracker. The frames per second was 30, object's mass was 0.085 kilograms, the observation start time was 0 seconds, the initial position of the object was 0.04145 meters, the object's initial velocity, which could be calculated by getting the average velocity, which I got 9.22 meters per second, and the observation end time was 1 second. And here are the initial conditions I used for GlowScript, which was basically the data I got from Tracker. As you can see, here's the mass, initial position, and initial velocity, the start time, and then the size of each time step. And here are some of the equations that I used that I converted to code on GlowScript. Line 58 shows the position update formula, and line 60 shows the velocity update formula. And here is a video of me running my program. And this shows the computational model, which is really similar to the tracker model that I showed earlier. Same thing, the object moved from left to right, and also here is the graphical results from my computational model. The left graph shows position versus time, so as time increases, position also increases, resulting in a positive slope, while velocity versus time results in a constant slope of 9.22 meters per second. And here's a graphical comparison of my model versus experiment. As you can see, in the beginning, the lines were very similar, but towards as time increased, the lines sort of diverged. So what if when I analyzed my video data in Tracker, I made a choice of flipping the X and Y axes? I said that the data would be reflected across the X axis. So the direction of the position and velocity would be flipped. So instead of positive slope, it would be a negative slope. And the results would be the same because the magnitude of the position and velocity would also be the same. And is it possible to say how many pushes and pulls were added together to give a zero net force? I would say no, it's hard to say how many forces are added together to give a zero net force, because obtaining constant velocity was difficult because pushing on the container could have caused acceleration, and other forces like friction and air resistance could have slowed the velocity down, and what errors were present in the experiment. Some human errors, such as inputting data in GlowScript and Tracker, and also it does not account for any motion in other directions. And that is the end of my lab. Thank you for watching and have a great day.